in your applications, in your projects? Sometimes, yeah. Yeah, again, this is a tricky one. Like, it's complex. You have an easy way not to do it. You have incentive not to do it. But if you want to do it right, you can follow open and close principle. Single responsibility. Again, this is something which Stephen talked for an hour. And there is a reason why I have this as my first slide. What Stephen stressed, probably the key takeaways from his session was, like, keep a class as simple as you can, right? Keep it limited to a single responsibility. Let it do one thing and do it correctly. The only way, he mentioned the definition was, okay, the only way in which you should change it, there should be only one reason behind changing a particular class. So again, if you have more responsibilities inside a single class, what will happen is that class will have more chances of getting changed over a period of time, right? Because it is having more responsibilities, and thus it will be more error prone as well. So he talked about how all the classes should have low coupling, like have many classes and have them do one responsibility. Do not have classes which are overlapping. So make it more cohesive, like everything about a single functionality should be there in a class. So that's kind of making a class more cohesive. So that was the key takeaway from his session. Again, open and solid single responsibility is kind of, it lays the ground for every developer to bring in other design principle. So it's like the base foundation. So if you want to follow, implement open and close principle in your application, it's pretty tough if you don't follow single responsibility at the first place. Okay. Moving on. So what are the key objectives and takeaways from this session? So we'll look at the exact definition of open and close principle, which was first laid down by Bertrand Meyer way back in 1988. And also there was a more verbose definition which Uncle Bob provided. We'll look at few of the code smells which open and close principle tries to resolve. Why exactly you want to apply open and close principle, right? We'll look at few of the bad practices, few of the bad code smells. How do you detect code smells in your application? How open and close principle helps you get rid of those code smells. We'll look at few of the fundamental concepts. Again, I'll brush through few of the concepts like abstract classes, interfaces, virtual methods. Like, if anyone is not aware, they can at least understand what we are talking about here. Again, open and close principle cannot be applied in all the scenarios. There are some exception scenarios which you should be aware of. It's not like, okay, I need to follow open and close principle. You walk out of this room and you go ahead and change your application. Yeah, you need to be aware of few of the exception scenarios for this principle. And then I have some couple of demos. We'll look at, so we talked about an application, a Concode application way back in September, I guess, last year for the local .NET Conf local event. So it's kind of on the same, building on top of that concept. Say, if I want to develop an application or a conference application which takes in registrations, say I charge an amount for registrations, and then there are a few discount codes, say early bird discount. So probably that concept, I've created a new .NET Core app, and probably we'll go through that. It's not yet tied to Concode, but I wanted to show before and what's the after state. So I've figured out that it's better to have a separate console app to demonstrate this. Okay, so this is kind of the main definition which Bertrand Meyer laid down in his object-oriented book. And this was way back in 1988, and I guess it still holds true. So it said software entities should be open for extension and closed for modification. Anyone explain what do you mean by open for extension here? Anyone from the audience? Anything, whatever comes to your mind when you listen, when you hear about open for extension term.
That the code should be easily extended, but you shouldn't be able to modify it, or you shouldn't need to modify it.
Awesome. Okay, that's a good definition. Closed for modification. What does that mean? Closed. How do you write your code if you close it for modification, right? Yes, sir.
You're not changing the original source code, but the extensions allow you to modify the behavior while still leaving the original as it is.
There you go. That's correct. So open and close principle is kind of a guideline for the overall design of your classes and your interfaces, and how you can make it open for changes in the upcoming days, right? So when you're working in your project or in your application, you might be having your sprints or iterations, and one thing which is you are pretty sure of that you'll always get new requirements or enhancements, right? So you should always keep that in mind when you are working on say, creating a new class. Okay, try to figure out if that class will be changed. Does it have a chance of getting changed in the upcoming iteration? And if yes, then think about open and close principle and start creating your classes in such a way. Okay, so again, you will always have new requirements coming up, so keep that in mind. You can, so it's a tough concept, right? How do you extend your code, right? How do you close your code for modification, like without making any changes to your source code for a particular functionality? How do you implement a new change? So we'll go through those. I'll talk about how do you extend your classes, and as well how do you close it for modifications. A more verbose definition which Uncle Bob he provided was for open for extension, you must be able to satisfy changing requirements and support new features, right? Whatever changes are coming in. So if you have a tightly coupled, your classes are tightly coupled. So even to make a small change, right? Even say you need to make a change to a rule, even though it is a 2-line code change. But if your class is tightly coupled, you will need to make changes to multiple places. You will need to spend more time in testing, and that basically delays your movement to production, right? So that's the crux of this. And closed for modification, you must be able to extend behavior without editing the existing code. Okay, so say you have a discount calculator class. Right? It has 4 discount rules inbuilt. Business comes up and says that, okay, I want to add a new discount rule. So what you can think of doing is, at that point, okay, I can go ahead and modify my existing class, add a new rule, and create some unit tests and go with it, right? That's the first approach you will think of. But what about, say, in one of your applications, say the discount calculator class? Think about if it is a huge class with 1,000 lines of code. Again, that defies single responsibility. But if you are in such a situation where your class is pretty big and you have multiple classes tied up with that single base functionality of discount calculator, even to make a 2-line change, you'll need to spend efforts, right? You need to test it. You don't know what is breaking if you make a small change. So the other approach, which kind of explains closed for modification, is you create a new class where you explain, okay, what is the new discount rule which business is providing. Create a new class. Write tests around those new class. And think about it. The new class which you are now creating, that doesn't have any tie-up with any of your legacy code or with any of your existing code which you have in an application. So once you test it out, start plugging it into your existing application. You can, there are different ways in which you can create those extension points, which I'll be covering up. But maybe either by interfaces, abstract classes, so you can plug that back into your application and then you can write some integration tests, and you know that you are not, there are high chances that you are not going to break any existing functionality, because what you just did was you created a new class and plugged it in, right? So that's kind of the definition which of closed-form modification is. Now, anyone has any questions on these two couple of definitions, because this will drive the next few slides and even the example. So we need to be pretty confident on what these two principles states. Any concerns of doing this? Okay. So I think I've convinced everyone. That's good. Okay. So once a class is deployed to production, or say you have clients which have started using your service or your application, do not make changes to that class. That's what open and closed principle says, because for your client, even say you might interpret a 2-line change as a modification to your existing code, but for them it's a new requirement which they are providing to you. So they want you to implement that new functionality, right? And you shouldn't be breaking any of the existing functionality. So you'll plug in the new functionality and break something else. That's something which always happens, but if you follow open and closed principle, probably we can stop that happening, okay? So once a class is done, it's done. That's what closed form modification is, that you do not make changes to your source code once it's live in production and other clients are starting to use those. If there is a new requirement, you just create a new class. You push that class either by inheriting, if you can implement by using an interface, and you can plug that back into your application. So there are multiple ways of doing it, but that's the crux. Client meeting. This is something which I could think of. What happens when you go to your clients, happened to me as well. Now, when you go to your clients, they always have new requirements. And the one thing which, if you talk about, okay, how much time it's going to take, the first question which they will say is, okay, why is this small enhancement going to take so much time, right? And you will have probably your golden answer, those 2 lines, where you will say, okay, development is simple, but testing is going to take time. How many of you have given that as a reason? Like one of your changes which you are working on, you will say, okay, development maybe 1 day, but to test it out, we need some rigorous testing, and it will take 2-3 days to test that. Now, I see that as a code smell, right? Why about, like, you know that your changes are simple enough, but to test it out, if you think it's going to take more time, so that means that you have a problem in your code. You can explain it in a way, as I said, you might have a class which is 2,000 lines long, and there are a lot of things going on there. You're not following single responsibility principle. And if you want to make any changes to that class, probably there will be cascading effects on other classes which have the similar functionality, which are kind of relating to each other, and you don't want that. So how to get around that, right? You don't want to spend too much time on your testing. Now, same thing. You need to create classes. You need to you need to think about how you can extend your functionality, create new classes, create new unit tests. So if you have say a bug, you have a lot of unit tests covering all your class files. And to implement one of the new requirements, say your existing test cases fail. So those scenarios, right, you shouldn't ever have to change or make your existing unit test work again. So whatever unit tests are there, they should work. And then for your new functionality, you should create new unit tests, okay? So what are these code smells which we are talking about? Blake talked about those. He made use of those terms, but we will try to see what are the different code smells which kind of stand out. The first one is rigidity. It's like if you have interconnected, tightly coupled modules, what's going to happen if you make changes to them? All of those needs to be recompiled. All of those needs to be retested. And again, you need to redeploy those, right? So that's a problem which you have if your classes are tightly coupled with each other. So even though the changes are small, it will have cascading effects on multiple classes. Your changes, you'll end up having to make changes in, say, 10 different classes if you have tightly coupled classes. Second one, fragility, right? Again, it's tough to make changes when you have your classes tightly coupled, right? You change something and you think that, okay, you have done, you have completed your code change, but you inadvertently, you break some other functionality, and that you come to know after pushing their changes to production. So that's bad. So whenever you see any places in your code which is fragile, try to address that, is what open close principle tries to say. The third one, immobility. So I worked in one of the projects back for an insurance company, and the way that project was laid around is it had multiple components which can be, they wanted it to be individually deployed at any particular point, right? And when we started looking at that, probably it was a legacy code. Over a period of time, I guess developers came and gone, and what happened was it was all tightly coupled. There was no way for me, like business, they used to say that, okay, deploy this component and we should be good. And that's what it worked 5 years ago. But the code is not in that state now, because in the last 5 years, we had made changes and we had not followed solid principles, and it's now in a messed up state. So if you have an application where you have different components, if you follow solid principles, what you should be able to do is you can kind of maintain a loosely coupled classes, and that will give you the ability to deploy individual modules into production separately. It shouldn't be like either I can deploy all of them or I can deploy nothing, right? You should be able to deploy a single module into production anytime. One does not simply close a class to changes, right? So this is kind of the most toughest part. So when we get a change as developers, it's pretty tough to adhere to open and close principle, and especially that close to modification part is something which is the most toughest, right? You have a class, you know that, okay, you can make changes to it, it can be done, but again, if you follow OCP, it says do not modify any of your existing classes. So there are few exception scenarios to open and close principles. So any guesses to what are these exception principles? Any wild guesses? Like scenarios where you can actually skip open and close principle.
Well, I'm trying to think of a scenario in my head
Yeah.
of just something really simple and going back to the employee class.
Mm-hmm.
I mean, if it's black and white, do not touch it. Let's say you have the employee class and you just want to have a second address field.
Yeah.
How would you address that if you can't touch it because it's closed?
Right, that's kind of adding some traits to your classes. So like if you have a class, classes are all about traits. Interfaces, I will come to interfaces, they are about functionality. So it's kind of, you can add traits. It's the functionality which you are trying to, the responsibility which you are trying to build inside your class. That's what kind of I'm implying with closed for modification. You cannot build any new functionality or responsibility inside your class. That's kind of answers your question. Yes, sir.
I'm kind of struggling to commit to thinking that the kind of class that was used in my app, it's not distributed, it's not used across the whole world in my business app. I want to change the methods, do something to it. I find the 3 places in my code base that use that class and all that method. I deal with whatever the change is going to bring back and propagate. I deal with that. I hit run, it cleans up, works, run the test suite,
Yeah.
all good.
Yep.
No new class, it's almost like you could spend more time working around, making the change, changing the other things that need to change as a result of that.
Yeah.
Cleaner than all the other work required to avoid doing that.
Absolutely. So that's a good question, and that's kind of the biggest challenge for developers when they are trying to think about open and close principle. I agree completely to that. Again, kind of when you know that, like the scenario which you mentioned, it throws some code smells, right? You kind of have some tightly coupled classes as well. So you kind of start thinking from there, and again, how to extend your code, say that by interfaces or by abstract classes, you can do that. And I have some cool demos where I have a similar example where I have an application which doesn't follow open and close principle, and how do I modify it to start following open and close principle. It's additional work, I agree. It's kind of complex. That's true even. But there are benefits which you can reap from open and close principle. Say, if you make changes to your existing classes, there is full probability that you can break an existing functionality. So the only way in which you can break your existing code is when you make changes to it. That's what open close principle says, okay, don't make it, don't do that. So we'll try to see, again, it's a difficult concept. We'll try to, we'll be going through some of the slides as to, I'll try to break it up, how to take those small steps and finally go reach there probably. Yes, sir.
Just really quick, you're talking about changing functionality and everything like that. Would you, at this point, start leaning more on polymorphism and overloading functions?
Absolutely.
Where you would just take that piece of code that already works, pull it in as a parameter, and then use your new class to modify that functionality and then just add it in that way?
Absolutely. So kind of, you just talked about polymorphism, yeah. That's the way in which you will be able to extend your class. So by using, say, abstract classes, virtual classes, method overriding, what you said, that's the way in which you will extend your functionality. So that's the route which we'll be going through in this presentation. And that's how you achieve open and close principle. Okay, I was talking about exceptions to open and close principle. The first exception is when you have a defect, right? So say you have pushed a feature to production and there is a defect. Once you have a defect, it's not like, okay, I will go ahead, start creating a new class, and you don't think about that. So this is an exception scenario where you have a bug fix to do. At that point, it is legitimately fine if you go ahead and modify your classes and don't follow open and close principle, right? So kind of how many of you are doing test-driven development out here? Ryan, okay. Ryan is a QA, so he's our QA guy. So now we have seen the benefits of doing test-driven development. We started with a project 2 years back, and doing test-driven development is tough. We had to, the initial amount of time which we spent just creating that framework, writing unit tests, making sure that each and every line of code is covered with a unit test, integration test, and we have automated tests to back it up as well. Like the initial few months were slow, but once we started, say after 3-4 months, once we started moving it to, say, really released one module, and then when we started, we had new requirements come in. There's where we started seeing the benefits of having, of all the efforts which we had put in behind doing test-driven development, right? Because with any new business rule, I used to get immediate feedback if I'm breaking any new existing functionality. I always trust my unit test that, okay, if any of my unit test breaks, then, okay, I've done something wrong. I need to go and look back as to what functionality I have broken. That's the most fastest response time, like immediate feedback which you will be getting by your unit test. And kind of what we did initially was we had no code, right? And we went to a room, Blake, me, Brandon, a few other developers, Matt was there. So we went to a room, we started, there was no code. We started writing a unit test. We know that there is no code, all right? That was the weirdest experience I had. So I was set to write a unit test on a blank project. So we started going through the requirements, started just laying down few unit tests and say, okay, these are the requirements which I need. And then we started writing, building upon our classes. And it was tough initially, I must admit that, but we have seen the benefits 2 years now into that project. Anything, all of our code changes are covered with unit test, integration test. We have automated feature test which runs. So kind of anything we break, we get immediate feedback. We didn't wait till business discovers that. We will know it right in front. So kind of how you work on your defects is, as I said, first, red-green refactor. All of you must have heard about this. So write a failing unit test which can recreate the issue which you are working on. So if you have a defect, go ahead and write a failing unit test. So you know that, okay, this is the scenario which business has mentioned, and since my code, since it's a defect, my code is not working properly, so the unit test should fail. Now, it can be a unit test if there is some other functionality which kind of goes beyond the realm of unit test. You can have a automated feature test as well. Then start making the changes to your code, and once you put in your code changes, it should automatically go green, right? And then at a later point of time, you can come back to your changes and start refactoring them. So that's kind of the crux of how you work on your defects. Red, green, refactor. You need to have a defect. You need to have a unit test to replicate all your that exact defect. I'll quickly show an example. Okay. Guys at the back row, can you see this, or should I increase the font? Okay, it's good. Okay. So this is the .NET Core app, and probably it's a conference registration project wherein it has it basically has I've kept it simple. So it has a class discount calculator which takes in the amounts, and depending upon the discount type, it will calculate the discounted price for your conference. Again, I'm running this on Visual Studio 2017, and it's update 15.3. This is currently in preview version. I'm taking the risk of running it. The only reason why I'm doing this is because during the build conference last month, Microsoft announced the 15.3 version, and they said that live unit testing will be supported for .NET Core projects as part of this preview version. So it's kind of preview version. They have they recently pushed out another update, preview 2 for 15.3. I guess they mentioned that during the fall time is when they will push this. But yeah, the live unit testing works great. Just make sure that there are still few bugs. I'm just trying to validate if it's working. Okay, it's working. So have anyone of you worked with live unit testing in Visual Studio 2017? Okay, have you worked with NCrunch? Okay, awesome. So again, we use NCrunch at work as well. We are trying out to see if live unit testing will help us to do test-driven development. That way we can get rid of NCrunch as well. I'll go through this application, what it is. So this, I have two folders basically. I have a without open and close principle, so pretty cut and dry. I have a class file which does the conference pricing. I have a enum basically which tells about all the discount type codes which I have, early bird, group code, a VIP code, and then I have unit tests around that. So basically I'm doing all my verification of the prices, whether that's correct or not. So I have a failing test here. That's because I modified it to make sure that it's working or not. Let's wait for some time. Okay, so the tests are green now. So say you have a defect in your code wherein business comes and says that, okay, the VIP code, okay. The VIP code, which the percentage of discount which you are providing is incorrect. So instead of 0.5, it should be, say, say 60% discount you should provide to your VIPs. So what do? You just come to this class, discount calculator class, look at this piece of code and say, okay, this is my pain point, so I can just fix it by making it as 6, right? Putting it as a 0.60 and you have it done. How many of you will do that? Okay. Kevin, out of all. Okay, so if I do that, what's happening is I've not even recreated the issue, right? So probably the first step which I should do is, okay, I will look at, let me look at the line and the unit test which covers this line. So I have a valid unit test which covers this. So it says, should calculate discounted price for VLIP code discount type. And it calculates the final, the original price is 1,000. And if I'm providing 60% discount, my final price will be 400, right? So I'm trying to reproduce the defect or the changes which business mentioned so that I have a failing unit test. So now, and this is again a simple scenario so that all of you can see how it works. But I have a failing unit test now. So what I will do is now go back to my discount calculator class and make that change. Okay, immediately went green. So that's kind of the way in which we will be actually tackling any of the defects which we have, create a failing test, make the code changes, let it go green, and then refactor it at a later point of time. Whoever has worked with NCrunch, so it's kind of a bit different. So the way the live unit testing works is you need to have your text explorer opened up. So there is no nifty symbol at the bottom which says that, okay, how many tests you have. So NCrunch gives you, so if I think I have the same code opened up in 2017 15.2 version as well. Let's see. No.
It's on the other screen to the far right, bottom far right.
Where? Yeah, I'm not able to.
There it is.
Yeah, there it is. So this is the same, this is one more demo which I had, but the way you are seeing, okay, the NCrunch works is it has a nifty symbol at the bottom which says, okay, how many tests you have, and when you start making changes, it will show you how many tests you have broken. It's not the same as with live unit testing. You need to have your text explorer opened up, but kind of what Microsoft mentioned during one of the sessions at Build was NCrunch, kind of when you make any change, it constantly keeps running your code, and it will run all your unit tests, and whenever you make a single line of change, say you have 300 unit tests, it will run all of them. They have made live unit testing a bit more intelligent in the way that if you're making changes to your discount calculator class, it will be intelligent enough to just look at the classes which are surrounding that, and it will just run the unit tests which are around those associated classes. Run just 15 unit tests instead of running the entire suite. So, Any questions here? Yeah.
So what if it's not a defect? What if they come back and say, we want to change the percentages?
Right. So say they introduce, say, give us a new discount type to.
Or even just change the percentages of the existing.
Yeah. So that's something, again, a kind of, I'll treat it as a defect. Like you have implemented something, it's there in production, but they are just now trying to change that particular percentage amount. So we will kind of forego open and close principle at that point and just go ahead and modify the existing code. It's only when, say, they say that, okay, there is a new group code, say a new discount code which you need to implement. At that point, we will try to think of, okay, whether I made changes to this class or should I start thinking about open and close principle and not change any of my source code and create a new class, okay?
Create a new enum too, right?
You can add to that existing enum as well. Yeah.
It's not closed.
Kind of. You're not making changes to your discount calculator. It's like the functionality which is built in, it's inside discount calculator, and that's something which you're trying to close for modification. So the enums, again, you can keep on adding to that, if at all. Okay. If I'm able to get my slides back up. So there is one more exception to open and close principle, which is client awareness, right? A change is allowed. You are allowed to make a change to your class as long as none of your clients are using that. Say you just started working on your project, on a new project, and you know that probably in the next 6 months, it's not even going to production because you have just started to work on it. No one is using your application or your service at this point. In that scenario, again, you can defy open and close principle. So these are the two exception scenarios which Uncle Bob, and it's there in the Clean Coder book, saying probably you can forego open and close principle if you land up in this scenario. So again, Stephen as well talked about loosely coupled classes, right? Which is a good thing to do. If you have your classes as loosely coupled, you can start making changes, like you can build up and probably apply any of the good design principles. If you have a tightly coupled classes, that's a code smell which we should try to avoid. We'll start talking about how do you open your classes for extension, right? That's a difficult concept. That's a difficult thing to do because that will take more time, more effort, putting that structure in place where if there is a new discount rule coming in, instead of modifying the code, you will start creating new class files. So this is one example which I could think of. What do you mean by open for extension? All of us have cell phones, right? The cell phone, it comes up with a default functionality, like you can call, you can text, you can click pictures, right? Think about a scenario where I need my cell phone to give me additional functionality, like say I want to play a video game, or I want to track how much I'm walking, how many calories I'm losing. What do you do in such a scenario? You go to your app store and you download an app, and that's you have extended your functionality of your cell phone to provide a new range of capabilities, right? So that's something which I could think of when I said open extension. Again, it's all about creating those, trying to identify or creating those extension points. Simple example which I just fetched from internet, an image. So you have a train and you have a compartment which you have said, okay, you should be able to transport coal from one place to the other. So what you do is you have a compartment, you put in coal there. Next requirement comes in, okay, I need to transport some boxes there. So what do? You have some boxes, you put it in the same compartment, and then Steven won't be happy because it has defied single responsibility principle, right? So what basically you do is you add another compartment, put all your boxes there. Say, if you're required to carry more mails, so add a compartment and put all the mails there. So it's all about identifying what your extension points are. These are my extension points, right? Coming back to our C# code, our project, what are these extension points which will represent these? So basically there are two types of extension points. One is the implementation inheritance and one is the interface inheritance. So to extend your code, you need to rely on abstractions. You need to rely on inheritance, like you said, polymorphism, right? All those concepts. You need to, anytime, say, you need to create a virtual method. If you have a parent-child relationship, by creating a virtual method, you can override it in your child classes. So implementation inheritance, you can apply by creating virtual methods, abstract methods in your code. Again, interface inheritance, by creating interfaces. There are a few scenarios where you need to have interfaces, like creating base classes or creating abstract classes won't help you out. So you need to have interfaces there. How many of you know what a virtual method is? Can you explain, any one of you? Just a brief description of what a virtual method is. Any takers? Okay, sir. Yeah, that's true. If you have an inheritance, if you have a high level and a low level class, say a parent and a base class and a child class, if you mark a method as virtual in your parent class, you are saying that, okay, to the child classes, say you have 5 child classes. So you are saying, if you want to go with the default implementation which I have provided in the virtual method, you are free to go with it. Or else, if you don't agree to that, you can override it. That's what a virtual method is. And again, that's one of the way in which you can extend your classes, right? So you have a base class, mark it as virtual, and in the child classes, you can override the default implementation of that functionality. And that can be a separate class which you can create by your own and then plug it back in. And you can just use, you can just inherit from that base class. So any class that marks one of its members as virtual is kind of open for extension, right? So virtual methods try to put in a difference between what a virtual method and an abstract method is. Because when you start working on a on inheritance on a base class, child class, right? It's kind of, you need to understand what are the scenarios where you can apply, you can make your classes or methods as virtual, and when you can make it as abstract. So virtual methods, if you mark it as a method as virtual, you can override it in your child classes. Same concept goes with an abstract class as well. But abstract method, the only difference is abstract method doesn't have any implementation of its own. So in a parent class, you can just put in an abstract method, but you cannot have any default implementation, right? And when you come to the child class, and if that child class inherits from that base class, you are forced to actually provide an implementation to that particular abstract method. And that's how you try to extend your code, keeping in mind just if you're focused on inheritance. Any questions here on virtual or abstract methods? Okay. I'll kind of show a quick example as to what I just talked about. Okay, I have a Come on. Okay. No? Okay. So Steven showed an example of a employee class. Building on top of that, I have two classes here. I have a full-time employee class and a contract employee class. So if you look at full-time employee class, it has properties like traits like employee ID, first name, last name, get methods like get full name, and then it calculates the monthly salary. Contract employees, again, few of the similar traits will be there on the contract employee, but again, the difference will be it has an hourly rate, hours worked, and the implementation of the calculate monthly salary is kind of different with contract employee. Now, when you look at these classes, the first thing you think is, okay, there are some duplication within this class. So what you can basically do is you can create a base employee class and take the common functionalities out, put it inside the base employee class, and everything should work as is, right? The problem is, there are two things which I can do. I can mark, if I just create a base employee class, while implementing that, I can easily create an instance of base employee, right? Nothing is stopping me from creating an instance of base employee, which is not right. There's nothing called a base employee, right? It's just for my convenience that I'm doing a base employee. So if you don't want to instantiate one of your parent classes, what you can do is you can just mark that method as abstract. That way, you won't even, it will give you a compile time error if that happens. Say I have a abstract class demo where I did the same thing. What I did was I took out all the common traits inside a base employee class, employee ID, first name, last name, get full name, calculate monthly salary. What I have done is I have marked this method as abstract. Okay, so I'm not providing any default implementation to this. Once I go to my contract employee, it inherits from that same base class. And in here, for the calculate monthly salary, I'm overriding this method from the base class, and I'm giving my own implementation. That's how the method overriding, which you talked about, method overloading, overriding polymorphism works on. So same thing on the full-time employee. I can override this functionality here. One thing to mention here is on the base employee class, I have put this method as abstract. Again, if I want to provide a default implementation, I can just mark it as virtual and provide any default implementation, and everything should work again, right? If I have, say, I just created a program class. So I'm instantiating full-time employee, contract employee, and remember that I have my base employee marked as abstract. So if I uncomment this line, it should immediately throw me an error, compile time error saying that, okay, you cannot create an instance of this method of the base employee because it's abstract. So moving on. Again, I talked briefly about abstract classes. You will need abstract classes when you see some code duplication in multiple classes and you want to move those duplicate codes into a base class, and you do not want the base class to be instantiated, right? This example which we saw with the base employee, that's the scenario where you will go with an abstract class. And obviously the advantage is your code maintainability is easier. You don't have to change in multiple places in your code. I have a fun example to demonstrate this. Say you have a person class. It has few traits. I talked about like classes are just traits, interfaces are functionality. You look at a monkey class. There are common traits between them. They both have hands, legs, eyes. They both have hairs. So you look at a particular behavior, which is, say, jump, right? Person jump. Look at the same behavior with a monkey, and you say, hey, I got some common behavior. So let me do one thing. Let me inherit, let this monkey class inherit from the person class, because we have the same behavior, which is jump. It's good, right? We are reducing our duplicacy. But the problem arises when you have say, a Boolean method trait saying person writes code, right? And now that the monkey has inherited from person class, now monkey has access to that method, right? That's a kind of violation to the encapsulation principle, right? The monkey class now gets access to a lot of other traits which it shouldn't have access. So kind of you can get rid of this scenario, this problem, if you have an interface in place. So you cannot rely on abstract classes all the time. So if you had an interface called iJump and I write code, so that way what you would have done is the monkey class could have just implemented iJump but not iCode, and the person class could have implemented both that interface. So coming back to one more critical concept, which is multiple class inheritance. Can anyone explain, like C# doesn't support multiple class inheritance, right? All of you know. So how do you actually implement that in your code if you had to, say, inherit or from multiple classes? How do you do that in your code? You're still able to do it, but how? Like if multiple class inheritance is not allowed, what is?
Composition,
Absolutely.
putting an object in the other object.
Awesome. Yeah, we can do that. And this is kind of the diamond problem, which kind of explains why multiple class inheritance is not allowed and why it kinds of makes the entire inheritance thing very complicated if multiple class inheritance was allowed. Think about a scenario where we have 4 classes, class B and class C inherits from class A, and class D inherits from B and C. You have a method in class A, say a virtual method. It provides a default implementation to a particular functionality, and which has been overridden in class B separately and in class C separately. Now, if in class D I'm trying to call the method in class A, now class D doesn't know how this has got, like, does it need to take the functionality which B has implemented or C has implemented. That's the whole problem with multiple class inheritance. So the way in which we can get around is multiple interface inheritance. So you cannot inherit from multiple classes, but you can inherit from multiple interfaces, right? That's the crux and how we go ahead writing our code. Again, why interfaces? I'll just touch base. I know Brandon, Rob, Blake, all will be talking in details on this topic. But again, interfaces, they are just declaration. They do not have any implementation. The classes which implement that particular interface should be providing the definition of what that method should do, right? It's 5 minutes, okay. So interfaces, again, the biggest advantage is it helps you build loosely coupled systems. Since your definition is in one place and your declaration is in different place, it's easy to write unit tests, and it makes your code much easier if you want to build on top of that. Again, I have just these 2 images. Say you have one class which is X is depending upon Y here. Again, if something changes in one of the classes, other has to know about it, right? It's kind of tightly coupled here. So the way in which interfaces helps here is like X, this class doesn't need to know anything about the specifics of class Y, right? It just needs to know what Y is providing. It's not bothered about how it is doing it. So there's where you plug in an interface and you implement, the class Y will implement this interface, and that's the dependency inversion principle, which Brandon will be covering in detail. But the final result of such a design is X is no more dependent tightly on Y. X is more flexible, and obviously you can create more unit tests easier. Quickly go with a demo. So I showed you the example where I had a discount calculator class and different discount types. Think about business comes to us and asks us to add a new discount type. So following open and close principle, what you can do is you can go ahead and add. So let's look at how I have broken up the different discount codes here. So basically what I did was I have created a discount service class now. I have all these discount rules which I had. I created a new class for an early bird, for a group code, and for a VIP code. Okay, and what that class is basically doing is there is an interface which I have defined, which has two methods, which is calculate the price and just is discounted, whether it's discounted or not. So these classes, the early bird classes, it implements that iDiscount service. It has two methods which it will try to define, which it will try to implement, and I've put in my code logic out here. Instead of having it in the base discount class, it's all inside the early bird discount calculator class here. Same way, we have group code discount. It's basically kind of broken up into 3 parts now. So think about a scenario where we need to implement a new discount, a new code, discount code. I can just add it to this enum. I can create a new class, which I was thinking I was planning to do that, but I guess we are short of time. But we can add a new class out here, and all which will be required for me is going back to the discount service class and adding that class. Again, if you're using a DI container, you don't have to new it up, but you can add it here and everything should work as is. So the unit tests, again, what I'm doing is I'm trying to new up the discount service class, and again, it's pretty cut and dry. The same way in which the unit tests don't even need to know what happened here, what is the change. It's all on your discount service, which the changes were made to. So think about any of your scenarios in your code. So kind of a common way to identify where you can implement open-close principle is if in a class you have a lot of if-else statements, or you have some switch statements, or you know that, okay, you have one of the classes which there are high probability of that changing in upcoming iteration. Think about how you can start opening it for extension, that concept. Last slide. It's kind of just sum it up, and we'll look at what are the benefits of open and close principles. So obviously you don't have to change your working code. You know that your existing functionality is not breaking because you have created a new class, you are just plugging it in. So it's not tied up with your existing, all your legacy code which is there currently in your application. You don't need to fix broken unit tests. So if you have to fix broken unit tests, you're not following OCP. So what you do is you write new class files, you write new unit tests to cover that. New classes have no legacy coupling, which I said. Like requirements will be coming in as part of your iteration or as part of your sprint. That's inevitable. So kind of think about how you can build code that that kind of will accept changes over a period of time. Don't make it tightly coupled, which will make, for making even 4 lines of code changes, you will take 4 days of time, right? Try to make it loosely coupled and just your thought process and get there. So again, the final thing, you move more changes to your production faster. That's what we achieve with open and close principle. I guess that was it. Any questions? I know we are running short of time, but we haven't.
Just so we don't let the food get too cold,
Yeah.
while we save questions, the plan is basically to get the food, bring it back in here, and then we're gonna keep going.
Yeah.
So just a few